Hey people, how you doing tonight? Welcome. Welcome back if you've been here before. If you're live watching me now, hey there. I'm your neuroscientist, Dr. Andrew Hill, or I'll be your neuroscientist tonight anyways. And it's been a little while. I'm back after about a month or so off. This is the first Neurofeedback and Chill of the new year. You know, people tend to start their New Year's resolutions in February, so I took the month of January off. And I'm back every Monday night, 6 p.m. Pacific. Over the past month, I've been finishing off a book manuscript for a book called Gifted and Tortured, which talks about the phenotypes, the brain patterns of ADHD and stress and anxiety management, some social and sensory things. And that's done. And I've sent it off for a proof copy, and I'm going to release that probably next week. I'm going to announce pre-orders, and then I'll create a small list, 150 signed copies for the first 150 folks that want to purchase directly. And then you'll have to go to Amazon after that. So I'll probably announce that next week as soon as the edit is done. If you're live, let me know how my audio is, please, how my video is. I know my quality sometimes can be a little iffy. I think it's okay right now. Okay, let's see. So if you're new, this is a weekly Monday talk where I hang out. I often strap electrodes to my head and do some neurofeedback, or at least talk about some brain topic relevant to neurofeedback or other brain science. So, you know, grab a drink, grab a snack, say hi in the chat, and let me know your questions. Again, some housekeeping. If you want an advanced copy, or at least if you would like an announcement when the book is released, please sign up. There's a link in the show notes, and we'll get those off to people. The first 150 will get signed copies if you want. And tonight we're going to switch into talking about some brain resources, brain metrics, and brain networks. This is something that we often get into when thinking about supporting regulatory features of brains. And I don't know how often I've talked about autism, but I have a lot of experience working with people with atypical, whoops, I can't sign in. Let me sign into my, for some reason, YouTube keeps signing me out. And it wants me to keep signing in again and again. So let's see if I can sign in here. If I can't, oh, I'm not going to do it. So this is a little bit annoying. Sorry, guys. I want to sign in so I can see you. Asking questions. Let me sign back into YouTube. Here we go. It's like 75-factor authentication. For some reason, it's having me do it 3 or 4 times in a row. Okay, here we go. Let's see if this works. Okay, continue to YouTube. All right, so I can see the stream. I can see the stream health. And I can see the chat questions. All right, I'm back. Thanks, guys. Thanks for hanging out. I see Radar Ashwood is here. Hey, Doc, long time no see. It is. It's been about a month or so, a little bit more. See Ryan's here. Ryan has a question. Favorite protocols for reducing chronic muscle tension? CZSMR drastically helps mine, but makes me so exhausted that I can barely function. Any idea why? Ryan, the short answer is probably the frequency of the SMR is too slow for you. I would try to go up by 1/4 hertz or 1/8 of a hertz in speed, and see if you get some of the same body relaxation. You can also try other variants that are not straight CZ. You might get something similar from T3 minus T4. You might get something similar from CZ if you start off with C3 or something in a faster beta and then move to CZ in combination. You might be able to buffer those effects and still get the relaxation, but also get some tone, some beta tone. So I would try faster hertz If you're doing 11 and a half, go up to 11 and 3/4, maybe 11.625, stuff like that, and play with that. Those are small enough adjustments you won't see much difference. So I would stay with short segments while you're experimenting. Hey, Leo, how's it going? Nice to see you. So tonight we're going to talk about autistic features, and this has been sort of bugging me for years. I've been working on autism for years. It's a big area of neurofeedback, and I got into neurofeedback through my experience working with latency aged kids in psych, with kids with atypical development in autism, as well as other areas. And I ended up working in a neurofeedback center and saw amazing change. And I saw it in a landscape where I didn't think it was really possible. And I saw, changes in eye contact and seizure, sensory tolerance, obsessiveness, bedwetting, all kinds of developmental shifts in kids that were, not little tiny kids that were developed to some extent, and adolescents. And it was really, really kind of amazing. But even back then, as I was getting more deep into the autistic landscape, and I was working in an autism center in Providence called the Neurodevelopment Center, there was a lot of heterogeneity, a lot of differences across autism, right? So back then we had labels like PDD-NOS, pervasive developmental disorder, not otherwise specified, and autism, and Asperger's, which is kind of like essentially autism without a cognitive component to it, mostly the pure social. And those labels have changed, and the newer DSM has variants of autism, levels of autism. The thing is, the levels are really grading degrees of difficulty, and they're not really cohering with the underlying phenomena. One reason why, although I don't love the history behind the scientist Asperger, the name Asperger's was useful because it shows another category of features that are very different sometimes from traditional, if you will, autistic buckets. And you also have these days this kind of concept of AU DHD, the autism and ADHD kind of overlap. And there is some variance. There is some validity to that idea of these phenotypes co-occurring, and they're creating a combination. Now, people are also quite variable, so I think that we break down a little bit when we try to categorize ourselves too tightly into one or two labels. And so while I think this is useful for thinking about the autistic spectrum of features, I don't think that getting to an autistic diagnosis is necessarily always the most useful thing unless you're trying to get accommodations or you have severe need. Because I do think many of the resources that we talk about are tractable or changeable. And that's true in things like sensory, social, executive, anxiety. I also see these features co-regulated or dysregulated together in the brain across all kinds of diagnostic language and complaints, and we'll talk about a few of the brain resources, cortical resources that I see as we dig into these areas. But some new science has been done in the past couple of years. And what's changing right now is that across this sort of same label but different brains landscape, what's emerging is different imaging and EEG is revealing subtypes within the autistic spectrum label or category. And these are really different wiring phenotypes. And they map onto essentially different flavors of autism to a large extent. So let's back up. Again, we think about autistic spectrum, one spectrum here. And for decades, research lumped ASD individuals when doing research into groups, and there was less distinction across functional levels when doing research, and there was much less of a theory around differences across autism that was able to parse out research populations. And so this, in hindsight, this is sort of obvious. If you're trying to measure what one phenomena is and you're clustering different phenomena, you're going to get sort of weighted phenomena or averages of the overall thing. So recently, a bunch of teams flipped the logic on that. If you cluster within the autistic group, do you see subtypes? Do you see different patterns? And so the first study I want to talk about is an MRI study that pulled out joint patterns of gray matter and resting state connectivity, and classic autism had a different brain signature. It had more subcortical connections, more default mode network disruptions than the sort of Asperger's or high functioning, cognitive versions of Asperger's. And these old categories, they weren't random, but they were crude. They weren't fitting the data very well. So another team used fMRI, functional blood flow activation MRI, and they found 3 different subtypes within the functional connectivity. One had widespread hypercentrality, so a lot of connectivity, a lot of activation down the midline. One had localized individual spatial, modular abnormalities. And one had closer to typical brains, but with specific network deviations as opposed to regional deviations. And each of these 3 really lined up with a different symptom profile in autism. So the takeaway here is that autism is a bit of an umbrella over a handful of recurring brain architectures and phenotypes, but not a continuous distortion or set of complaints. And it's not a spectrum in that you go from one end to the other and you get worse and worse. It's more that there's different things that can show up on this tree that you are of different resources. So sometimes that cramps up into things we call autism. And, there's neurodevelopmental severe versions of it, which are very clearly things that are in the way. But then there's this sort of edge case, again, that we're calling AUDHD perhaps, where I would wonder if we're getting different types, really, not something truly that's in the same developmental perspective or degree of dysregulation, degree of organization of challenges. That's very obvious when you talk to somebody who's very high functioning with largely intact social stuff, but has quirky skills and obsessive interests and a touch of OCD and a touch of ADHD and a bit of difficulty with social cueing or has some quirky verbal prosody. That's a very particular interaction compared to somebody who's high functioning autism, HFA, who's lost all verbal prosody, who doesn't understand social information, who's cognitively largely intact but not perfectly intelligent. So you have these sort of distinctions even at the high level that are somewhat obvious. And there was a 2024 paper that looked at this clustering around language, cognition, and then motor skills, and found 2 robust subtypes. Type 1 had higher language, higher cognitive skills. Type 2 had more global delays. And these didn't just score differently, they showed different fMRI patterns and different relationships between brain connectivity and gene expression. So different biology underneath different behavior. I would argue that these are not truly the same, thing anymore. A separate study found that behavior, if you looked at behavioral measures with structural MRI, functional MRI, and gene transcriptions, they found 3 subtypes once you included the gene transcriptions and the structural, functional, and the behavioral measures. And they found each of those 3, again, not severity on a line, like a spectrum getting worse, but 3 distinct places and different neurodevelopmental stopping places or nodules on this string of pearls. So this dovetails with the phenotype model that I'm going to unveil next week in my Gifted and Tortured book. If you'd like a copy, sign up for an advance notice. You can do that in the show notes. I see somebody laughing. Good job. So the idea that neurodivergence is divergent hardware configurations, divergent phenotypes, and strengths and trade-offs exist in various types of phenotypes. But here in the autistic landscape, we actually have sub-phenotypes below the label of autism that cohere out. And there's early interventions that these subtypes respond differently to different interventions. Things like oxytocin, for instance, can work in creating social function in some people who have autistic spectrum flavors, but not reliably, not always. So this starts to explain why some of these things are different. All right, the next part of this to talk about is, do we see some of these differences on EEG? And the answer is yes, to a large extent we do. If you look at meta-analyses, you can see that there's changes in autistic spectrum groups that look distinct. There's one group that has alpha and faster ranges, betas up into the gammas. That's very informative. And the alpha power seems to dip, and that creates this sort of difficulty with detail-focused perception. And then elevated fast frequencies, beta all the way up into the gamma, those get flooded and seem to track with difficulty with social reciprocity. And then you have globally elevated theta, which produces a lot of fronto-central connectivity that's dysregulated and hypercoherent. And you end up with front midline theta features like obsessiveness and tics and those sorts of things. You can also look at, this is a little different than classic QEEG, but those geeks on the channel right now will love this. There's something called microstates. There's brief whole brain sort of timing patterns that roll through the brain doing things. And one of them, called microstate C, runs in these little timing loops that are between 40 milliseconds, closer to 50 really, all the way up to about 100. At the lower level of perceptual awareness is 40 or 50, and then 100's a leisurely, 120 is a leisurely awareness. The full loop of information as you observe something and then act is usually around 180 milliseconds on the lower edge. It can get lower, but usually you're not acting, you're reacting, and you're not necessarily acting well. You're a bit sloppy and favoring speed over accuracy once you get below about 180 milliseconds. And the reason for that, largely, just as to take a detour, a digression, the reason for that is the information takes time to register in the brain. We don't perceive something the moment it hits our retina or the moment it hits our cochlea. Those first steps of the machinery to take sensory information and transform it into brain energy happens at the retina or the cochlea, and then it's transformed. The retina is the simpler, the vision's much simpler. There's one step basically into neurons, the information sorted between the left and right visual fields into the left and right hemispheres, just behind the eyes, and then it hits the thalamus, and the thalamus and the areas behind it, the visual tissue, those are largely the first time we're aware of something. And so it takes about 2 neurons, literally, to get to the thalamus when we first might be aware of it, and another 2 neurons to go out through Forel's fields and then to the visual tissue to get into the actual true awareness. And so you're talking about 60 milliseconds to get to the thalamus, maybe 40 or 50, in somebody very, very young, very strongly myelinated. And you're really talking about the awareness of it creeping in up around 70, 80, 90 milliseconds. Decision-making takes 40 or 50, and then there's action. So you see why we're bumping up against 180 as sort of like a lower level for high performance, but, still controllable. All right, so other folks are showing up. Hey, Guy Soleil, nice to see you. Yes, you made it. That's wonderful. So we have this group with low alpha power and elevated gamma, elevated beta. And then we have these EEG microstates. And microstate C is this little rapid temporal loop that's looping through, allowing us to think. And this is different in some of these groups, this sort of deep processing speed. And you'll see this, I think, in resting speeds of things like delta and alpha. Those are generally dysregulated quite a lot in autistic spectrum people. You'll see in more global dysregulation, you'll see delta waves speeding up hugely to 2, 3, 4 standard deviations above average. Delta is typically in high power. The same group will have elevated front midline theta, elevated global theta, elevated beta and gamma as well. So they're sort of hitting everything. So the 3 archetypes that tend to show up, if you take that research that I mentioned and you kind of line them up with the QEEG, I would say that there's 3 QEEG phenotypes that are the sub-archetypes, if you will, of the autistic spectrum landscape. One would be the default mode network light archetype. It's sort of the DMN, the awareness of self, the self-referential stuff is running in a way that's underconnected. And the posterior, the sensory, the social are not totally checking in perfectly. And there's low power alpha, there's low connectivity, there's hypercoherence, there tends to be a lot of anxiety. a lot of cingulate activation, a lot of perseveration, rumination, sensory stuff, because the modules seem to be running hotter individually. And there's weaker long range coupling essentially. And this group will have trouble shifting between inner and outer focus and get absorbed internally. And if language is not there, this is somebody who's stimming and scripting and having a lot of difficulty breaking repetitive sensory habits essentially. So these individuals, if the cognition and language is relatively intact, can process plenty of details, but sometimes can't assemble the social gestalt, the social overall meaning, the implicit information. And they can feel socially like they're watching the world from far away and not quite understanding the social information. Let me stop and answer questions that are building up. Leo's asking questions. What QEEG findings actually predict response to neurofeedback and autism? Leo, what I would say is if you have the features that I'm going over now, they should be tractable to neurofeedback, and therefore these are they. But generally, to answer your question, probably in a more useful way, there's certain functional levels I find that if you're above that level, you can get great results with neurofeedback. And if you're below that level, it's a much slower process for some resources. The hardest resource to work on is language. It does not maintain a plasticity. It has a critical period, unlike things like attention and social and sensory, which do have some ability to regulate and to change over time. So if someone does not have receptive language, the interpreter part of the brain that receives information, extracts the meaning of the language, the right parietal area, Wernicke's and surrounding areas. If someone doesn't have that working really well, then they're not going to have other language probably develop. It doesn't come out of nowhere. But if somebody has decent receptive language and a little bit of productive language, more Broca's, more front left, the speaker of the brain, the output, then they'll usually develop more language resources with neurofeedback. Those are the harder cases, the language aspects. But if somebody has a relatively typical brain, AUDHD or Asperger's or one of those, you'll get very strong impacts on not the autism label per se, but on the sub-resources, on the perseveration or the inflexibility or the inattentiveness, or the sleep regulation, the sensory integration, like issues with texture or food, let's say. These are all things you would work on individually without worrying about the label of autism as much, I would say. Instead, worrying about how people are suffering, if they're suffering, and which of the resources in the QEEG should be related to that. So back to that, the first archetype is this frontal theta, front midline theta heavy, hyperconnected. Sorry, this is the second one. The first one is the DMN being kind of light, kind of underconnected broadly, and the posterior area is running super hot. The second mode, the second archetype is a frontal theta. Front midline theta is super high, elevated theta is super high, and you have a lot of impulsivity, a lot of sensory flooding. It looks a lot like ADHD. Often, especially in kids, they get both diagnoses, or people argue about which it is because it can look like both, depending on context or the level of engagement, the level of structure, the level of interest. So this archetype, this front midline theta or frontal theta, this brain is overwhelmed not because the signal of information is too loud, but because the filter is kind of running slow. And you'll have a lot of scripting and repetitive behavior here as well. You tend to have a lot of, in somebody who's cognitively intact or gifted, you'll tend to have a huge amount of procrastination as the anterior cingulate runs fast alpha and has trouble getting out of that fast alpha mode up into a beta mode. You can think of that as the anterior cingulate having difficulty reconciling between the cognitive appraisal of approach on the left and the cognitive appraisal that things are worth avoiding on the right. And so you'll see a lot of that difficulty with behavior, the ADHD, ASD sort of overlap. And then you'll have a group that focuses more on the sensory with the beta and the gamma super high, elevated connectivity everywhere, especially in the back of the brain, especially sensory and social. You will see very little coupling across different networks. Alpha will be chaotic. You'll see very poor coherence, very high phase lag at alpha. Alpha will usually be dragged down super low. Sometimes it runs off the charts high in speed, and the delta is usually super high amplitude as well. And these individuals will be running all the individual modules in super high gear. This is the individual with a crazy, intense sensory experience. People that are hearing fluorescent lights, people that are feeling the tags in the shirts constantly. The really, really super high channels. They'll recognize certain things incredibly well. But then again, difficulty integrating across those channels. So the resolution's cranked up, but the bandwidth is very narrow and flooded. So we have those three archetypes again. There's the default mode network light, low alpha power, not very self-referential, trouble shifting between inner focus and outer focus, looks a little inattentive, missing the social information a little bit. Then you have the front midline theta and broad theta, which is that ADHD overlap with a lot of like OCD features, tics and scripting. And then you have the super high sensory and social flooding, which is more betas and gammas and super, super intense. The same group with their decreased connectivity and increased local modules would show savantism as well. Incredible gifts, but also very strong difficulty using them outside of narrow contexts. All right, so those are the archetypes. What do you guys think? Anyone see themselves in one of these? Drop a comment in the chat, either live or later on. I'll read them. I'll leave comments if I can. So again, these aren't formal QEEG, diagnostic categories, but they're plausible EEG phenotypes. That's the landscape of QEEG, by the way. It's not a diagnostically precise thing. It's looking at people compared to the populations of people. People are weird. So, don't worry too much if you're not in the middle of the bell curve. That's not really the point of looking at human population data. Instead, you look for phenotypes, patterns that usually show up, and then figure out what they often mean. And if you're in the landscape of understanding yourself through that, you have agency. You don't have a diagnosis, strict truth. You have possibility. If your front midline's making lots of theta and you find yourself having lots of intrusive thoughts or biting your nails or having a tic, well, it could be your front midline theta. Train that down with neurofeedback, see if it goes away. Or if you have a lot of front midline beta and you have intrusive thoughts, well, now it's more of the OCD flavored things. N-acetylcysteine, methylation analysis, neurofeedback, SSRIs, lots of things can work on that. So again, not medical advice, take this as education, but I'm a big fan of understanding your phenotype. So even though I've given you three archetypes for autism, you probably know, or you know if your kid or your friend or whoever you take care of has these archetypes. I would argue that the individual pinch points or suffering or cramps within this become the more important thing at the individual level. And this speaks back to Leo's questions about, what's a marker for response? Well, a target. If you have a target to go after in the QEEG, things are generally tractable. And then we know some other regulatory things like sleep, seizure, migraine, things you wouldn't see in a QEEG. We know some of those are very tractable too for most people. So, and we know those things are very common, right? There's Jay Gunkelman talks about the research that shows that in neuroatypical neurodevelopmental populations with autism spectrum and other related features, the incidence of subclinical seizure disorder is incredibly high. In different populations, different complaints, it's higher than others. But across a bunch of different spicy people, OCD, anxiety, language issues, autism, there was a very high correlation, like better than 25% of those people have atypical subacute seizure phenomena. This is probably why neurofeedback, which helps the brain suppress seizures if you do SMR training, it's probably why it works so well for so many things in a neurodevelopmental landscape. Some of that is the sensory motor tone helping the brain suppress seizure activity. Leo's offering brilliant. Thank you, Leo. Appreciate it. Guy Soleil, with Soleil, it's probably Guy Soleil. Bonjour, Guy Soleil. Sensory disorder. Okay. I don't know what that is in French. Sorry. Although in French, ADHD is tada, which I think is just divine. TDAH. Tada. It's a very ADHD thing. A way to think about it. Leo's saying all this knowledge with $1 million. You bet, man. Thanks for doing this. Of course. My pleasure. You know, I'm glad you found it useful. I'm glad you guys are enjoying this. But like, why does this matter that we break these things down? Well, it helps us, you know, understand ourselves as I'm describing at the individual level, but also it might inform research moving forward, right? Historically, if the research has been mixing subtypes, mixing physiology, complaints, behavior, well, that'll make it hard for us to understand what autism is, what works to support it, etc. But if we're able to create these three networks, these three archetypes within autism, then we can probably think about ways of supporting precision research, but also precision care. You know, I can imagine a time where one would think, phenotype DMN-lite, okay, train network integration, alpha theta work, connectivity training at midline, you know, bring down cross hemisphere sensory stuff, you know, T5, T6, T3, T4, etc. Or maybe it's fronto-theta-heavy. Now you do your FCPZ with a theta inhibit instead of a beta inhibit. You get response inhibition, bring up some SMR along the way. This is that, again, AU-DHD kind of overlap. Sensory gamma, high flooded beta, slowed alpha and sped up delta, bottom up sensory integration, cross network coordination protocols. Maybe think about the infra-low or infra-slow if you have access to it. Regular neurofeedback works great as well there. You know, I think it works better because that's all I do. HEG can work for the frontal theta as well as the DMN-lite group powerfully. So the point of this is none of it replaces this label or diagnostic utility of autism. But instead of saying your brain is autistic, we say your brain is running this architecture, these strengths, these cramps, this dysregulation, these phenotypes. Here's how you work with it. Different hardware, not broken. So these are research grade biotypes or phenotypes, but multiple teams, multiple methods are all converging on the same conclusion. Autism is many related brain types, not one. All right, so if you guys want a follow-up designing neurofeedback for each archetype, or you want me to dig more into autism with regards to the overlap with anxiety or ADHD, or how we think about HEG with regards to autism, drop a note and I'll do a future video that unpacks those more. Again, next week, I think I'm going to drop Gifted and Tortured. So if you want to be one of the first 150 people to get a pre-release purchase option where I sign it and send it off to you directly, and then ask you that if you liked it, you can leave a review for it somewhere. Please sign up in the link in the description. So back every Monday for this year. Took a month off after 18 months or so of doing it, and I'm back now every week. So subscribe if you liked it. Hit the thumbs up. Maybe hit that bell to get notified, and I'll see you next week for the next topic. But let me answer some questions from the Peanut Gallery. Leo's asking, which autism symptoms have the strongest evidence for improvement with neurofeedback? I don't know about evidence. I would say it's probably the executive function ones or seizure, Leo, for evidence. But in terms of strongest impact, anxiety and sensory stuff and executive function things are the strongest. Remember, with regards to neurofeedback, the three legs of the stool are sleep, stress, and attention. When I say stress, I mean all of the anxiety, perseveration, rumination, social, sensory, all of the over-arousal, all of the under-arousal things that produce anxiety. They're really foundational, and so is sleep regulation, which overlaps in some ways, and so is executive function regulation, which also overlaps. The sensory motor rhythm production ability that helps you suppress seizures also helps you not fidget when you're sitting still, also helps you stay asleep at night when a car goes by. So we use these resources in different ways, these regulatory resources, and sleep, stress, and attention need to be regulated. And they're often dysregulated in autism. And if you get those suckers under control, it's powerful. And I would say the degree to which any individual then needs work on the social, the obsessive, the ruminative, other aspects like that that's really unique to the individual. Even across these phenotypes, I would say, or these archetypes within the phenotypes, we often get, very different individuals with different complaints. So, you'll have one person who's got profound autism who can't handle any sensory information, who's got a lot of hot beta back here and doesn't make any eye contact. And you'll get somebody else with very similar hot beta and the right TPJ who like seeks sensory information, is always, looking for texture, things to grab, is always seeking eye contact, is always giggling, So you don't necessarily know looking at these features. It's still more fine-tuned. People are more unique than their maps. But any of these things that you see are generally things you can work on, which I think is the really lovely takeaway here with regards to autism, but also in general for brain mapping being a tool of agency for you. So Leo's asking, what are my thoughts on Neuralink? Oh, is that the Muskian mad science? I think that he solved a problem that didn't need to be solved that much. Robotic surgery basically was the problem he solved. We don't know the brain well enough for the BCI to work that well. As far as I know, he's not solved any of the foundational problems of the technology that are about mapping brain signals to information, that are about drift of the tissue underneath the wires. As far as I know, none of that's been solved. So all Elon Musk has done is create a robotic tree panning and implantation device. His whole company is going towards robots these days. Have fun. I don't think he's, I think he's, not all he's cracked up to be. So, and Neuralink was a bad company. Again, the product has done robotic surgery as their big technological differentiator, not brain interface. But when testing brain interfaces, they've also gotten in trouble a lot. There was a couple of studies where they were sending hazardous materials back and forth across, places, mailing them through the mail, and they were not sterile, and they had, there's some animal abuse complaints, and a lot of the research team quit because of how the research is being handled. So, as a scientist, I'm, let's say, nonplussed at best. As a brain computer guy, I'm dismissive because he solved the wrong problems. And interpersonally, I think he's a jackass. So, hey, El Chatterino, nice to see you. Any info on ASD and head injury and changes in experience or symptoms thereof? I don't know. I don't know if there's an acquired social and sensory and autism feature set in the concussion landscape or the TBI landscape. You would think there would be, but I don't know the literature there in that direction, getting social stuff from injuries. I have seen literature showing that if you have autism and other neurodevelopmental phenomena, neurospicy things, even like ADHD, you're much more prone to develop head injuries, to get a head injury. You're clumsier, you're less aware of your body. So there is literature showing in those atypical populations, the incidence of concussion is higher. But I don't know about producing any concussions. Concussions producing autistic spectrum features. You would think there would have to be some of that because you can exercise the frontal lobe's blood flow. You can exercise the temporal lobes in their posterior social and in integration of the outside world integration. And you can get changes in autistic spectrum features. So one would expect there's individuals with small strokes, small injuries, things like that, with individual areas blown out that would produce social issues. And you can sort of see that. I mean, it's not, again, it's not at the level of a systems experience. But if you take something like prosopagnosia, we have think about how a lot of these features work in autism. I mentioned the different archetypes, but many of them have, the social and sensory world, which comes in back here as part of the signature. And we do things like tone of voice, verbal prosody, often with the right one. And if you lack typical function in the right TPJ, in terms of tone of voice, you might develop a lack of prosody and talk like this all the time and not realize that your voice isn't lilting. That's autistic. That's a phenomena where it's hard for you to know about the lilt in voice that is encoding emotion and emphasis. And because of that, you're not monitoring your own quite as well. And it creates this woodenness in your speech emotionally, or this lack of lilt. Often there's a pitch or a tone to it, which is why I was using that. It's often a higher pitch than one would expect. It's not being monitored that well. And so that area has other social and sensory areas around it. And some of those areas, we do have specific diseases or atypical function in that do create not autistic level things, but things that could almost be the next door neighbor. And prosopagnosia is one of them. Essentially face blindness, or the inability to recognize somebody by looking at their face. You might understand their voice, or remember their glasses, or their favorite shirt, or something they always wear, or their smell, and use that to piece together who you're talking to or who you're looking at in a picture album. But the ability to look at someone and go, oh, that's so-and-so, based on their face, can be very difficult. And that's the fusiform face gyrus in that area. And that area is involved in autism and seems to be involved with eye contact. And if you do neurofeedback in that area, you tend to get more eye contact in people that don't give it naturally. And if eye contact is overwhelming for you, training that area to relax makes it less overwhelming. So we know it's involved in autism, but if you get atypical function in the fusiform face area, it may be hard to connect it to other parts of the temporal lobe as you go to do face recognition. And prosopagnosia can be partial, where it's a little hard, all the way through complete, where people look like they're essentially all the same. There's no real distinction. It's hard to remember their indistinguishing characteristics. And so you can get prosopagnosia through head injuries or strokes. Therefore, there probably are people for whom they're losing social cueing, verbal prosody, social inhibition, etc., through acquired phenomena. So kind of a long walk there, El Chad. Thanks for going with me on that journey. I can see how it could happen, but I'm not sure of that direction. So the other direction, I would say if you already have ASD and you get a head injury, you're more likely to get a more exacerbation of the things that are already a little out of range. So you're going to get more slow brain waves, more depleted alpha power, and more sped up hypercoherent reactive beta. So more of a low and slow, but with also excess hypercoherence probably. And that'll look like post-concussion syndrome, i.e. exacerbated ADHD with increased sensory sensitivity and a lot of fatigue from exercise, from cognitive work, that kind of stuff. I think that'll happen much more likely to people who already have high levels of slow brain waves, essentially. All right, so folks, thanks so much for coming back. I really felt welcomed back to my first live stream of the new year. I'll come up with some new topics for you. A few folks are interested in some more work on Alzheimer's. I'll try to do at least one child, or I know autism isn't a childhood thing per se, but people often notice it in kids first. And so we think of it as one of the developmental, childhood things. I'll try to do at least one a month that's childhood focused. I'll try to do at least one a month that is aging focused, either Alzheimer's, some other disease of aging, or a healthy aging phenomena. So please leave notes about the things you would like. And then I will do at least one practical neurofeedback demo with Eager every month as well. And I'm not sure what I'll do for the last one, but I have a bunch of podcast episodes to start dropping as well. So please do me a favor, like and subscribe, share the channel out with your friends and your enemies. Fix your enemies. It's enlightened self-interest. Imagine how amazing it would be if your angry boss or drunk mother-in-law learned to self-regulate. So get on that. Hope you're doing well. Take care of those brains, everyone, and I will talk to you all soon. Leo's asking for TBI, please. We'll do some more work on that, you bet. All right, everyone, have a lovely afternoon.